Hi, in this session we are going to learn about preprocessor. Whenever you write a program and when you try to compile and execute the program, it goes through a lot of phases, right? The various phases is like first is your preprocessing, right? Next it goes to the compilation, and then it goes to the assembler, and then the linker and the loader, right? Each of these programs performs a specific task, and among this you can just observe the first one is called as a preprocessor. The name is called as preprocessor is basically it does all the job before the code is actually sent to the compiler, right? So this session is dedicated to understand the various functionalities done by the preprocessor program. Now let's try to look into what are the various functionalities done by the preprocessor. The first functionality is comment removal. Now we all know about comments. Comments are basically the statements written to explain what that code snippet does, right? When you talk about a regular code, those are the instructions given so that we want to perform some calculations. But sometimes the instructions will be so complex that suddenly if you want to look at it and try to understand what it does, it might take a lot of time. So for that, what we do it is in a descriptive form, we basically try to write what that code snippet does, right? Okay, in normal English sentences, that is called as comments. Okay, now comments are only required when the users looks at the source code, right? It is not required by the compiler. Compiler does not do anything with the comments. It's only when the user looks at the source code, okay, to understand what that code snippet does, we can write some description or documentation on top, right? That's called as comments. So comment removal is the task which will be done by the preprocessor. Now the other task will be done by the preprocessor is macro expansions, right? The macros begin with hash define, and we'll study more about macro expansions while doing the session. Then we also performs file inclusion. The file inclusions begin with hash include. That is also handled by the preprocessor. And then finally conditional inclusion, right? This has like hash if. Okay, so it's basically used to decide what code to include for compilation, what code to exclude from compilation. Now first let us look at comment removal. Here is a simple program to perform a very basic calculation. It reads two numbers from the user, it performs the calculation and then prints the results, right? Now I'd like to compile this program and execute it. When I want to compile this program and execute it, what do? I write GCC followed by the file name. The file name what I've given out here is called as comment underscore removal. And also please do observe, I've not written the hash include statements, right? I'll come to that, okay, very soon. I like to say comment removal, right? I like to compile. There's a warning, and in case if you include the header file, the warnings will be out. After that, I'd like to see what is the file generated. Can you see ls? What you can observe here is there is one source code and the other one is an executable. And how do we run the program? We write /a.out, right? So we can enter the numbers and finally the program is working fine. Now we have seen that it goes to a lot of phases. If you want to keep track of each of the stages, then what you can do it is while compiling your program, you can just write save -temps. Just use this option and it is going to store all the intermediate step files, like for example the result of preprocessing, the result of compilation, the result of assembler, everything it's going to store it. Now let us try to look at this. Now you can just observe that it has an executable, it has a source code, plus it has a file with extension .i, right? This file is the result of preprocessing. Okay, then we also have a file called as .s, the last one. What you can observe, this is the result of compilation, which is generally an assembly file, and then this is the result of assembler, which is an object file. Now we are more concerned about the .i file, the preprocess file. Now I just want to look at this file. You can open it in the text editor or you can just display it on the screen with the help of cat command. I'll try to use cat command, right? .i. I'd like to print this, and what you can observe here is the comments whatever we had written here, okay, all these comments have been removed. Remember, it's going to remove both the type of comments, either it might be a single line comment which begin with hash, right, okay, or even a block comment, right, like for example the block comment comes like this way, right, or you want to write something like that, okay, read two numbers using or you can say from the keyboard, right. I'd like to perform this. I'd like to just again recompile your program and then have a look. You can just see it's going to remove all the comments. Clear? Okay. So we have seen, right, how comments are removed. Now if you don't want to generate all the intermediate files, you just want to see the result of pre-processing. In that case, you have an option like GCC -E. E stands for expanded code, right? The file name. So you can just write this .c. It's going to give me the result after compilation. Sorry, it gives me the result after pre-processing, but does not put it into a file. It just displays it on the screen. Fine. Okay. Or the other option what you can do it is CPP. Here CPP stands for C preprocessor, because generally you might be saying CPP stands for C++, right? So okay, that's a different place, but here CPP stands for C preprocessor, right? I can just write this. Now this will perform the same task as what the previous command, GCC -E, right? So, right. We have seen the comment removal part. Clear? Now the next thing what I'd like to do it is, I'd like to include the header file, right? #include stdio.h. Fine. Okay. Now when you talk about the header files, header file contains the declarations of all your built-in functions. Like for example, let us say the printf and scanf's declaration is present in stdio.h, right, and many other functions, right? See, if you write #include stdio.h, what the preprocessor does is it opens that particular file stdio.h and includes entire content of that file into this particular file. So let us try to run this and try to understand out here. Please do observe the header file contains a lot of statements, right? So you can just see all those statements are displayed out here, right? Or you want to create a .i file and then okay, open the .i file, right? You want to open the .i file using vEditor or gedit, you can always do that, right? Let me just try to say comment removal.i. Okay, so there are many other #include statements inside that, and after that you can just observe that there are a lot of type definitions. More about type definitions we'll study later on, right? Okay, and I think we have used this int 8_t and all. You can just see how okay all those things is mentioned here. Plus you can also observe the entire function declarations of the printf. Like I can just try to write printf, right? So this is printf. Okay, various printf function is the vf printf, sprintf, and all those things. We'll just try to look at it. Fine. You can just see what do we see out here. Okay, please to observe it contains only the declarations, not the definitions. Clear? So the entire contents of the header file are included. Now while including the contents of the header file, there are two ways in which you can include. One is the normal way what you are using it, like angular braces. The other way in which you can include it is in double quotes. There's a small difference with respect to this. Even here you can just see there is no error. You can run the program, everything is fine. Let us try to look into what is the difference between including it in double quotes and including angular braces. Now whenever you try to include it in angular braces, it looks out for the header files in the standard directory, okay, where all the library, okay, built-in header files are present, right? But when you include it with the help of double quotes, then what happens is it looks out for the header file in the present working directory. If it is present, it's going to utilize the header file from that particular directory. In case If that is not present in the present working directory, then what it does is it goes to the standard directory where all the built-in header files are present. Clear? For any user defined header files, we try to place those header files along with the source files, and then we include with the help of double quotes. And for any built-in language standard header files, what we do it is we try to include with the help of angular braces, indicating that these are the standard header files of the C language and not the user defined header files. Now, to understand the difference between hash include and double quotes and angular braces, let me just try to create a simple header file. Now, what does the header file contain? I can just keep some simple information. I'll just try to write telling that extern int x, right? A simple statement. Okay, I'd like to save this. I'll say my head.h. Clear? Right. So you can also look into this file. The file is present out here. We can see the contents. Right now, here what I'd like to do it is I don't want to include this because what happens is like it is displaying lot of content on the screen which I'm not interested in. Now I'd like to include this header file in this place. Hash include. Now I'll try to write my head.h. Looks fine. Now remember, if you use a cat command, and if you try to write this file name .c, it gives me the source file, but I want to see after pre-processing. Then you have seen three different ways in which you can look at it. One is you can save all the intermediate files and then open up the .i file. The other one is gcc-E, the other one is cpp. Either one you can use it. I'll just try to use cpp followed by your file name. You're going to pass the source code file name, right? And then that's going to display the preprocessed code on the screen. And what you could observe out here is the statement whatever I had written in the header file, that is present here. Or might be I want to write something else, like for example, let us say I'd like to write int add int comma int. I want to do this, right? I've saved that file. You can just observe this. Extern is also present. The other statement is also present. Right now, this header file was in the same directory where the source file is. But now let us say I try to use this angular braces. As I said, when I use angular braces, it does not look out for the file in the present working directory. It looks out for the file in the standard directory. Now that standard directory here is like /usr/ include, but my head.h is not present there, right? So if I try to compile your program, like for example cpp filename.c, right? So now what you can observe here is it says no such file or directory. Why? It never looked out for this particular file in the present working directory. Clear? So whenever you're trying to use your user defined header files, always make sure that you include with the help of double quotes. Things are clear, right? Now the next thing is we need to learn about macros. You would have already studied about macros while doing very basic programs sometime, right? We'll just try to study that in more systematic way here. Now let us say I'd like to write a simple program wherein I just want to calculate the area of a circle. If you want to calculate the area of a circle, what will you do? You read the radius from the user, right? For simplicity, I'm just trying to assign the value, and after that I'd like to calculate the area, right? So let me just align this. Area equal to, what is the area? It is pi into radius into radius, radius into radius, right? Now I need to write pi. So when I say pi, one way I can use this value, right? Now instead of using the literal directly like this, what I can do out here is I can define a macro, right? The macros begin with as defined followed by the name. The names are generally written in uppercase, right? followed by a space, followed by the replacement text, right? What is the syntax? Hash define the name, this is the name of the macro, we call it as replacement text. Right. Okay. After that, whenever you want to refer to this particular value, you can just use this particular macro name. Right. Now, you might be wondering, oh, this is very similar to using a variable. I could have just used a simple float or a double variable and I sent the value and then I could have used the value. But there's a difference between a macro and a variable. Variables consume memory. It gets stored into the memory, either it might be stack segment or data segment, somewhere it gets memory, right? And the values of the variables can be modified. We can get the address of those locations, but macros do not occupy any memory, right? When you look at the source code, it looks like a variable, but in reality it does not consume memory like how the variables consume memory. Is this clear? Okay, right. Now I want to see the replacement text, right? So whenever I try to write this macro and use this one gets replaced to 3.14. So let me try to run this and show you the output. Right? Can you just observe the result of pre-processing is 3.14 into radius. Well and good, right? You want to print the result, you can print the result, right? So now you can even compile the program, right? Okay. This warning, because you have not included STI or touch, include that, everything works fine. Clear? Okay, fine. Now, what are the things what you observed here? First thing is we don't use equal to in between. That is what we generally use for assigning the value to the variable. The other thing what you might have observed is like semicolon. Now the question is, should we put a semicolon or not? Right? Okay. Now let us try to put a semicolon. Right? Generally we don't put a semicolon, but let us see what really happens if you put a semicolon. Will this give me an error in this particular line? This is my line number 3. Does it give me an error in line number 3 or not? Let me try to compile this. Remember, I'm not just seeing the pre-processed code, I'm just trying to compile all the stages, and I want to see if there is compilation is successful or not. If the compile is successful, I would like to run the program. If there is any problem, I'd like to observe where the problem is, right? And here what I can observe here is there's a problem, invalid argument to unary star. So when I try to look at it, I'll be wondering like, what is the problem here? I might not be able to understand. So but just try to print the pre-processed code, you will understand that you have a semicolon which is expanded here. Please do remember there was no error in line number 3, but here if you can just observe this, the float area equal to 3.14 semicolon, that is the end of the statement. Now this is basically acting like a dereferencing operator, more like a pointer. If it has to be a multiplication operation, this should be a left operand, but we don't have a left operand. That is the reason why it is throwing an error. I hope till here it's fine. So whenever you use macros, and in case if you're not able to understand from the error messages, I would say try to print the pre-processed code and it will be easy for you to understand the code. Right. Now let me also demonstrate the same thing, that in case if I had placed it here, I would not face any kind of an issue. Why I will not face an issue here? First, let me just show you that I'm not facing any issues. Then I want to show you that why exactly I'm not facing issues out here, right? Okay, sorry, I did forget, right? I put a semicolon there, right? I've compiled, no issues. I can even run the program, but I would like to know why exactly I'm not facing a problem. Is because the 2 semicolons out here, one semicolon which came along with the hash define, the other one what you wrote explicitly out here. Now till here this particular statement is perfectly fine, no issues. Clear?